Hi, I'm Rob Bloomfield, and this is Accounting with Our Bare Hands, a series of short videos exploring the mechanics of cost accounting. Today, the topic is cost volume profit analysis, which really isn't accounting at all. There are no debits and credits, but it gives us the fundamentals of the economics of fixed and variable costs and how they relate to profit. And so we're now, most students who take cost accounting have seen break-even analysis in marketing and in microeconomics, so there really won't be a whole lot new here. Hopefully this video won't take too long. Let's start with some very simple assumptions about a business. I'm going to assume that the business we're looking at has a product that it sells for $10 per unit, so that's the sales price, P. There is a variable cost of $6 for every unit that they sell, okay? And they incur total fixed costs, F, of $120,000. So typical break-even analysis, it says, okay, what we'd like to do is find the point at which the firm is going to break even, and I'm going to put that here as Q for quantity, how many units do they have to sell, sub BE for break even, and that's the number that we're going to want to fill in. Okay, so it's very helpful here to use graphs, and since I am artistically challenged, I'm going to use a straight edge. So here's a simple graph where here's the 0 point for both. We're going to have dollars on the top. We're going to have quantity along the x-axis. And the first thing we can ask ourselves is, well, how much revenue do we bring in? Well, revenue is going to be a fairly steep slope of 10, right? So this is revenue, and that's simply going to be 10 times Q. And then we can ask, well, what are our costs? Well, the first thing to recognize is that by the definition of fixed costs, even if we don't sell any units, we're going to incur $120,000. And then we're going to incur an additional $6 a unit. Okay, so now $6, right, we're starting at a higher point, but we have a slope that isn't as steep. And so this is F plus VQ, where V is our variable cost per unit, and that's $120,000 of fixed costs, plus 6Q. And here is our break-even point. Okay, and so the first thing that we can do here when we calculate our break-even is, let's just do a little bit of algebra. So what we're saying here is we're looking for the point at which this line equals this line, which means that PQ equals F plus VQ. I'm going to subtract VQ from each side, so we have P minus VQ, just collecting terms, equals F. And then to solve for the Q that makes this equal, right, so this is our break-even quantity then, is F divided by P minus V. Okay, so just one key term here, P minus V is the unit contribution margin. It's how much selling one more unit is going to contribute to, first, chipping away at our fixed costs, and second, actually getting us into profit. So one way to think about this, when we just plug the numbers we've got in, we've got 120,000 in fixed costs, and P minus V is $4. And so you can just ask yourself, well, how many times do we have to contribute $4 in order to have it add up to 120,000? Hey, well, just divide 120 by 4, and that's going to give you a break-even point of $30,000. Okay, so that's actually a problem, I'm sure. If you've taken marketing, if you've taken microeconomics, you have seen exactly this analysis. Cost volume profit is a little more general than this. We can add a lot of different questions. We can ask, well, what's the quantity we need to get in order to earn profit of 40,000? And, that's not hard to do. You just have to add in, then here, you're saying, well, PQ equals F plus VQ plus another 40,000 because we want our revenue to cover our costs plus 40,000. So there are a lot of different, you can also do this same math, but instead of solving for your break-even quantity, you can solve for the price you need to break even at a specific quantity, and so on and so forth. But there's one problem in particular that you may not have seen before that I would like to walk through with you now, because it's one that people often get wrong. It has as H.L. Mencken said in the early 1900s, every problem has a solution that is reasonable, simple, elegant, and wrong, or something. I'm paraphrasing him. But I'll show you what that is. First, let me describe the problem here. Let's assume exactly the same that we had before, with a price of 10, a unit price of 10, a unit variable cost of 6, fixed costs of 120,000. And now what we're going to do to change things is we're going to say, okay, here's the decision we're making. We're trying to figure out if we want to invest an additional $40,000 in equipment so that we can lower our utility costs by $1 a unit. Okay, so, we have a machine that is slightly more efficient, it runs more smoothly, it doesn't use as much electricity or whatever. And so I'm going to show this as delta F. This is a capital delta, Greek letter, and indicates change. And so what we're considering is a change in fixed costs of an additional 40,000 with a change in our variable costs per unit of minus $1 a unit. And the question is, for what quantity should we do this? So just as we can ask, you might think when you look at this, it's really, you're asking, how much do we need to sell in order for this this business to break even? Here we're going to ask, how much do we need to sell in order for this investment decision to make sense? Now, I'm going to draw the graph a little differently this time because it tends to be a more useful way of addressing the problem. And so now our 0 point is in the middle, and I'm not going to graph, in the last graph we graphed the revenue line and the cost line separately. Here I'm just going to jump right into the profit line. So remember, our profit line is just going to be PQ minus VQ minus F. So when, right, and so by the way, this is Q and these are dollars. Really, it's profit. And so our line is going to look something like this. Where here is our minus 120,000, because, right, if Q is 0, we don't get any contribution margin from any units, and we lose our 120,000 in fixed costs. And so, this goes up. This line here is right, so this is actually our contribution margin is 10 minus 6, so it's 4Q minus 120,000. And here is our break even, which we calculated before as being 30,000 units. That's where we break even. And now let's think about this new situation. We're saying we can add, we can add $40,000 of fixed costs. Okay? But we're going to increase our contribution margin. Instead of it being 10 minus 6 equals 4, we're saving $1 of variable utility costs every unit. So it's 10 minus 5 is 5. That's going to give us a steeper slope. So we're starting from a lower point, and we're going to end up with a graph that, actually I'll spread this out a little bit, a graph that looks more like this. Okay, so what's this equation? Well, if we don't make any units, now we're losing 160. That's this point here, and the equation now is 5Q minus 160. Okay, and just going back to our very simple, remember our simple equation here, where the break-even point is F over P minus V. It's, how many times do we have to get that contribution margin to totally chip away and eliminate our fixed costs, and then we start making profit? Well, it's just F over P minus V, so 160 over 5. This point right here is 32,000. So we've raised our break-even point to 32,000. Here's the big mistake that everyone makes. Not everyone. I'd say about half the people. Is that they say, so the answer to the question is we should go ahead with this investment if we have at least $32,000, at least 32,000 units of production. That's not true, okay? Because this is only telling you you will break even at 32,000 units of production. Actually, right? If what you want to do is compare your two alternatives. You're not asking, right? I didn't ask the question, how much do you have to produce in order to break even under the new plan? I asked, how much do you have to produce to make this extra investment a break-even proposition? That's going to be where these two lines intersect, which is here. Okay? And what is that number? Well, actually, the math is trivial here. How many times do we need to save $1 to make it worth investing 40,000 in fixed costs? It's 40,000 units. Okay? So really a pretty straightforward problem. Most of you, I think, probably didn't learn much new, and just though maybe it helped to see it one more time. But if you learned anything from this that you didn't get out of marketing or micro or wherever you saw this type of linear analysis, I'm guessing it's going to be this emphasis on how easy it is to make the mistake of focusing on the new proposed alternative and simply seeing whether you will break even under the new alternative, instead of comparing these two lines and focusing on whether you are making more or less profit compared to the old situation. So you can see actually between 30 and 40,000, you're better off under the old way, even though you break even and make money between 32 and 40. And then beyond that, you're of course making money on both of them, but you're better off with the bigger investment in fixed costs and saving variable costs on all of those units. Okay? So I hope you found this introduction to cost volume profit analysis, CVP analysis, useful, and I hope you'll take a look at the other videos. Thanks a lot. Bye-bye.